In this video, we'll take a look at simplifying cube roots with variables. Any variable with an exponent that is a multiple of 3 is considered a perfect cube. So if we have the cube root of x cubed, remember we can evaluate this by showing it as a string of multiplication. And yes, x to the third power is 3 x's. That's a triplet. That's 3 of a kind. So we write it once outside the radical. X to the 6th, there's 6 of them. So that means there's 2 sets of triplets. That's x to the second power. Notice too, we're really dividing our exponents. 9 divided by 3 is 3, so I'll have x to the third power. 27 divided by 3 is 9, so I get x to the ninth power. 30 divided by 3 is 10, I get x to the 10th power. So here we have our first example. It says the cube root of x cubed. Again, you can factor it out by writing all of your x's, and we're looking for triplets, 3 of a kind. I have one set of triplets. We represent that once outside the radical. Let's take a look at our values. 64. Was 64 one of our perfect cubes? Let's take a look. Factor it. 2 and 32. 2 and 16, 2 and 8, 2 and 4, 2 and 2. And we also have m to the third power, 1, 2, and 3 m's. So we're looking for triplets. So let's see, 1, 2, 3. Oh, and another triplet, and some more triplets. They're all perfect cubes. So this 2 triplets gets set outside the radical, and our m will be also outside the radical. The final answer to this is 4 radical m. 4m, sorry. No radical, just 4m. As we look at our next one, we have p to the 7th. We could go ahead and write out all of our p's. We're looking for triplets. I have 2 sets of triplets. So outside the radical, that'll be p to the 2nd power. But I do have this single p. That's going to stay in the cube root as a single p. Also, you could take 7 and divide it by 3. 3 goes into 7 2 times with a remainder of 1. The 1 is the amount of p's under the radical, and the value here is how many p's are outside the radical. Taking a look at our next one, the cube root of 512. 512. I know it's an even number. I'm going to start dividing it by 2. I'm going to keep dividing it. I'm going to keep going. That was a long branch. As we look for our triplets, we've got 1 set of triplets, 2 sets of triplets, and 3 sets of triplets. So outside the cube root, we're going to have a 2 times a 2 times a 2. For our m's, we have 5 of them. That's only 1 set of triplets. So I'm going to have 1 m on the outside, and I'm definitely going to have 1 m on the inside. And then my p's, I have 1 set of triplet p's, so that'll be on the outside, and 1 p will be on the inside. So 2 times 2 times 2 is 8 mp cube root mp as your final answer. -2, let's bring that along for the ride. That's going to go outside our radical. That's part of our final answer. And we'll break up 32. And look, we did 32 over here. So let's see. We've got 2 and 16, 2 with 8, 2 with 4, 2 and 2. We have a to the third power. We have b to the fourth power. And we have d to the second. If we go ahead and circle or look for our triplets, we have a set of triplet 2's. So let's kind of bring this down. We brought this -2 out of the radical. We have a triplet of 2's. That's out of the radical. We have a triplet of a's. We have a triplet of b's. Then we have these two 2's. They're going to stay in the radical. And we have a b that's going to be in the radical. And we have two d's in the radical. As we simplify all this, -2 times 2 is -4ab cube root. 2 times 2 is 4, b, and d to the second power. That's our simplified answer for that one. Moving on to our last example. We have a negative sign, so we know we're going to pull that negative sign out in front, and let's work on 48. Got 2 and 24, 2 with 12, 2 and 6, 2 and 3. We have 9 x's. And 8 y's. As we circle, we have a triplet pairing there, so that's also outside the radical. We have 1, 2, 3 triplets here. That's x to the third outside the radical. We have 2 sets of y's, so that's y to the second power outside the radical. When we look at what stays in the radical, we have a 2 times 3, which is 6, and we have 2 y's. That'll be y squared. Our final answer for this is -2x cubed y squared, cube root of 6y squared. It's always great to have an application or a real-world example of when you might use something like a cube root. So we have an example here. It says a cube has a volume of 512 x cubed centimeters cubed. Find the length for the side of a cube. So it's important to know the formula for volume of a cube. Volume can be found by length times width times height. Or specifically in a cube, because all the sides are the same, we can say it's a side length to the third power. And just like the name a cube tells you, its volume is something that has been cubed. So if we know our volume is 512x cubed, that's its full volume. And we want to know a side length. What can we do to find the side length if we know the volume is 512x cubed? Well, what we can do is go ahead and take its cube root. So we're taking the cube root of 512x cubed. (512) is a perfect cube. Its value is 8. If we wanted to, we can go ahead and do our factor tree. We've got 2 and 256. 2 and 128, 2 and 64, and we have x cubed, so that's 3 x's. So if we look at circling our triplets, 2 and 2, and yep, we've got 3 2's. All of this will be outside of the radical. So this is a cube root there. And we'll have 8x. This is equal to its side length. Now, volume is always just a something cubed, the unit of measure cube. That represents the fact that we're doing side times side times side. 3 dimensions are being multiplied together. But when we go ahead and take the cube root, our side length will have a unit of measure of just centimeters because we're also cube rooting centimeters to the third power. So this would be our final answer for that one.